So in this video, we're going to talk about suction line accumulators. Accumulators come in all shapes and sizes because depending on the size of the charge that the unit is put in, it has to be able to contain the amount of refrigerant that is going to be stored in it. So you have to size an accumulator according to the charge that is in the unit that the accumulator is being installed in. So the big question is, what is an accumulator? If you were to take a course, your instructor would say that the accumulator is either a refrigerant storage device or a compressor protection device. Years ago, the answer would be it is a refrigerant storage device. Today, in a refrigeration class, you would probably hear that an accumulator is a compressor protection device. I say it's both. It does store refrigerant in the heating mode when all of the refrigerant in the system is not necessary for the refrigerant cycle. And it also does protect the compressor by protecting the compressor from liquid being returned to the compressor that could cause damage. The suction line accumulator is found in the suction line as it comes from the reversing valve, and the refrigerant goes into the accumulator as a gas. And if there are any liquid particulates that are still in the refrigerant, the accumulator is designed to boil it off and return only gas or vapor to the compressor. So after the refrigerant goes through the accumulator, hopefully we only have gas being returned to the compressor. So therefore it is protecting the compressor from any liquid returning into the compressor. This is a cutaway of two different types of accumulators. The one on the left is pretty much a standard accumulator that has a tube coming in, and you'll notice the screen there at the bottom, which is the oil return orifice that we'll talk about in just a minute. The accumulator on the right was one that Carrier patented back when Puron came into the field, and it was designed to mix the oil and the refrigerant so you didn't have so much oil being left in the bottom of the accumulator. As I said, in the bottom of the tube in the accumulator, you have an orifice, and it's protected by a screen so it doesn't get plugged up. But often, if there is a bad burnout and the system is contaminated, the accumulator should be changed along with the compressor because the screen can become plugged with the sludge that's produced from for example, a bad burnout. And once that hole gets plugged up, the oil does not return to the compressor, and therefore you're going to have another compressor failure down the road because of lack of oil. This is the kind of contamination that can be produced in a compressor if it electrically fails or if the oil starts to break down and builds up sludge like on the picture on the right. If the compressor fails right away and stops running, normally this type of contamination does not escape the compressor and doesn't go out into the system. But if the compressor runs for any amount of time during the failure, it can pump this contamination and the sludge out through the system, and the electrical burnouts can cause major damage to compressors. The sludge and debris that is a result of a major burnout can find its way into the accumulator and plug up the return oil orifice, and this will lead to a second failure of the compressor down the road.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.